Welcome to the IC Realtime webinar series. I am Pat Carter. I'm the technical trainer here at IC Realtime. I handle all of the public and private webinars. If you're interested in hosting one for your team, feel free to reach out to me. I am Patrick at icrealtime.com, and I'd be more than happy to accommodate any of your technical or non-technical training programs. So welcome. This is part of a regular series. We have them on every Wednesday and Friday at 10 a.m. Eastern and 4 o'clock Eastern, which means we will be doing this webinar again this afternoon at 4 o'clock. If you have any colleagues you think would benefit from learning a little bit more about networking, learning a little bit more about connectivity with their recorder, please have them join us this afternoon at 4 o'clock. Friday's webinar will actually be the connectivity part. It'll be talking about encoding and actually fine-tuning your recorder to make the most of your bandwidth that you have available. But today we're going to actually talk about getting the unit online. So we're not going to get too deep into details about advanced networking. There are definitely other classes for that and other programs that will teach you about networking. What I really want to cover this morning is basically how to get your unit online, how to get it connected. So the very first step in a successful project is really incorporating, good morning, welcome. The very first step is really incorporating the client's IT staff. During the pre-project planning, during the job specification, find out who it is that manages their company's network. Is it an outside vendor, often called a VAR or a value-added reseller? Do they have someone on staff who manages the network? Is it the owner's kid who's away at college? Somebody knows the passwords for the routers. They know the IP scheme that's being used. Heck, it may even be you. So get familiar with the network, work with the IT staff, figure out exactly what the IP scheme is going to be. It really will make your life a lot easier further down the line. Residential applications, pretty much the same rules apply. Hopefully the client knows what the passwords are to their routers. If they don't, we can certainly use a wide range of default passwords. We know all the default passwords that most of the major internet service providers use. However, sometimes it does require a phone call to them to get whatever the password is to their router so we can set them up for remote access. So networking basically at the simplest stage is getting that network or getting that recorder or those cameras on your local network so that they can be viewed locally. And that's very easily accomplished by basically putting in a local IP address. Let me just move this over, bring this down. Here we are. I'm logged into one of my recorders and I have a local IP address. Now, physical connectivity is very simple. Every recorder comes with a patch cable inside of it. Normally, you would have just the ability to run that patch cable between the Ethernet connection in the back of the recorder directly to your switch or your hub or your router or your modem, whatever you have there. Hopefully, you have an open port available for you. In a corporate network, you may be working in a data center or a rack environment where they have some cable management, but essentially it works the same way. You're going to have a switch or a hub that you're going to be able to plug into. A great rule of thumb with that, be aware of your switches. If you plug your patch cable in the back of the recorder, you plug it into your switch, just like a Ethernet on a computer or your Ethernet on a wireless network, you should see immediately a green light letting you know you have connectivity, a flashing yellow light letting you know that there is transmitting data back and forth. If you don't have that, don't waste a lot of time troubleshooting patch cables or re-crimping wires or re-punching down wall plates. Go ahead and try another port in the switch. A lot of times a switch will go bad. An IT person will just quickly move that patch cable from one port to another, and they'll continue on. They'll leave that bad port there. So I've had a lot of cases where I've had installers that wasted hours and hours re-crimping, and then find out at the end of the day that it's actually a bad port that they're plugged into. In the 6 years I've been working with IC Realtime gear, I've seen one bad Ethernet connector on the recorder, so it's fairly safe to say that the NIC card on the recorder is going to be okay. The problem is more than likely going to be on the switch itself. Once you've got that unit set up, it's plugged in, you're on the switch, you're on the network, now you need a local IP address. Keep in mind that most local IP addresses begin with 192.168 something something. They can also have 10.0. something something, but primarily a 192 or a 10 address would represent a local or a internal IP address. Now, there are several ways to get your IP address. The first and easiest way, of course, like I mentioned before, is work with the client's IT staff. They'll give you an IP address to use. Maybe they've got the network set up in such a way that all the servers and NVRs and cameras are on a whole separate range of IP addresses, or maybe they've got it set up in such a way that they really want their cameras to be in a particular subnet or a particular range of addresses. So that's the easiest way. The second way is using DHCP. What DHCP essentially is once I plug my computer or my recorder or my IP camera into the network, it's going to immediately query the router, say, hey, give me a local IP address, and it will receive one. Remember, though, when you turn on DHCP and you receive an IP address, make sure you turn DHCP off because you don't want to keep getting new IP addresses later on down the line. The third way is find out what type of IP addresses are being used. Once you plug your laptop or you go to a computer on the network, you can go into the network settings and see what the IP address is and just kind of do a Hail Mary. If you see that the computer you're sitting on is 192.168.1 dot whatever, go ahead and pick an address high up the range, somewhere in the 200s, and hopefully that number is available. You want to avoid what's referred to as an IP conflict, meaning two computers or two devices on the network having the same address. For most residential, you're normally going to have very, very low IP addresses. They're going to be 192.168.1.2 or 9 or 10 or 12. So if you use something in the high 100s or 200s, you're going to be fine most of the cases. Let's go into the recorder. This interface is almost exactly like it would be if I were sitting in front of the recorder looking at a monitor. I'm actually going through the web interface. I go into my edit, and you can see this particular recorder happens to be an 8128. It has 4 separate network cards, but you can see I have an option here for DHCP. So if I DHCP, meaning I draw an address, that means it's going to let me get an address from the router automatically. And again, I want to turn that off as soon as I do get an address. The alternate to that is called a static IP address. We have static IP addresses on the outside in the internet. We also have static IP addresses on the inside. So once I give this recorder a static IP address, it's 226. It will always be 226. It's never going to change. So now this particular unit has multiple network cards, so obviously I want to give a unique IP address to each one of those network cards because I may be going across multiple networks. Are there any questions about IP addressing before I move on? Cool. Let's go ahead and close this out. The next thing I want to talk about are ports. Now, there are certain ports that are used on your network for connectivity of different types. For example, HTTP traffic is primarily used by Internet Explorer, by your web interfaces, your Google Chrome, Mozilla Firefox, and Safari. It's a very common port. HTTP is basically the main pathway that all traffic on the internet goes to. In most cases, we're going to use port 80. That's often referred to as an assumed port. Let me go into my networking under my connections. Now, in this case, I'm actually using port 80 for something else. So I have to use port 88. You can use multiple ports for your HTTP traffic. It really doesn't much matter. You want to keep them in a particular range, usually around 80 or 8080 are the most common HTTP ports. If you're using port 80, you don't have to put anything else in the address. If you're using anything else, you'll notice this example here. When I'm going to the local IP address of this recorder, I have to put :88 because that's the port I'm using. Now, when do you need this? When do you need to change it from port 80? Primarily if you have multiple devices that you're trying to connect to HTTP wide. So for example, I've got 4 recorders at my location. I have each one of them has their own unique HTTP port. If I go to port 81, I'm going to recorder number 1. If I go to port 82, I'm going to recorder number 2. It makes life a lot easier for you when you're accessing those devices from the outside. The other thing is sometimes you'll have other devices already using port 80. If you're in a residential, it could be the PlayStation. If you're in a commercial, it could be their web server or their internet email server. So port 80 is a very common port, and you're going to run into a lot of cases where it's already being allocated. Back to that rule number 1 with working with the IT staff. they'll be able to tell you exactly what HTTP port they want to use for web traffic. And this is important, again, because not only is it needed for the outside access, but it's very important on the inside access. So even if I'm on the local network, I want to access this recorder, I have to go to port 88 to get to it. So that's an important port to know. The other port I want to talk about is the TCP port. TCP ports are primarily used by your phone app. So if I'm on the local wireless and I log into my local IP address, I'm going to use the TCP port in order to connect to it. That's used by our Smart ICRSS as well. So if I'm in a big corporate network, maybe I'm not outside, everything's within the same local network, I would use that TCP port. And just like HTTP, you want that number to be unique on every device. Perhaps you've got a bunch of IP cameras that you want the ability to log into each IP camera individually. You'll want to give each camera its own individual HTTP and TCP port. The last port I want to talk about is the UDP port. This is a very secured port. It's used a lot in corporate networks. You see it a lot on very large corporate networks. It's very secure. It's also very slow. It's often referred to as the top-heavy port because it really does have a lot more security built into it. There's a lot more handshaking going on when you communicate across UDP. And again, some corporate networks are going to require that, so you'll be using that port for your phone app, or you'll be using that port for your Smart ICRSS. So just keep that in mind. Again, all of these ports need to be individual. They all need to be unique to that recorder. Just like each recorder has its own unique local IP address, they're all going to have their unique ports as well. And just to recap, HTTP is for the internet, TCP and UDP are used by the phone app and Smart ICRSS. Any questions about that? Cool. I'm going to let you in on some ancient Chinese secrets. These are some things that we use in our own help desk. Setting up your router is pretty easy, believe it or not. And one of the coolest things about IC Realtime is that our technical support, where you can call ahead and make an appointment to have them call you back at a certain time. They can call your tech on site. They can do port forwarding for you. All of our guys here are senior level network engineers. There's not a router they haven't seen yet. They can help you with your firewall. They can help you set up. When you're doing port forwarding or setting up your router for remote access, that same rule applies. Go to your IT staff. If they have control of that router or they have control of those switches, let them set it up. They'll have all the expertise. They'll know exactly where they want everything done. As an installer, it's going to make your life so simple because really all you're going to want to do is plug everything in. They'll tell you where to plug it in. They'll tell you what addresses. They'll tell you what ports, and they'll set the router up for you. If you don't have that luxury, IC Realtime can certainly provide that service for you. If you have a tech on site with a laptop or you have a client whose computer we can log into, we can go from the inside of that network, set up your router for you, create your port forwarding rules for exactly everything you need, and you'll be good to go. So port forwarding is essentially creating rules inside the router so when traffic comes from the outside, now I'm looking to log into that location remotely, I'm going to be logging in from the outside, hitting a particular port, normally port 80 for example, or in this case port 88, and when that traffic hits that port on the router has a rule created in it to automatically forward that traffic through that port directly to the NVR, or the DVR in this case. So once we get logged in, it hits the router on the public IP address and goes immediately to the device. That's port forwarding. Now, the alternative to port forwarding is referred to as port opening. A lot of your internet service providers can do this for you as well. They can set the routers up, but they're not nearly as advanced as we are here at the help desk. So what they may do is open your ports, which is what you want to avoid. The alternative, it's kind of, to put it in perspective, a port forward is like building a hallway from the front door directly to the guest bathroom. You can't go anywhere else. The only place you can go is that one location. Port opening would be propping that door open. So portforward.com is a great website that we use a lot, especially if we're working on routers that we're not familiar with or we haven't worked with before. Portforward.com is definitely something that all of your installers should be aware of. If I go to it, I click on my list of routers. It shows me all the routers that are available. I can look at all the different manufacturers. I can even click on little shortcuts to get to it. Today we're going to go to Linksys, which is a very common, popular router that you see out there. We'll skip their little ad. There's all the part numbers for all the different Linksys routers that are available. There's a lot of them. Let's go ahead and click in one of these older ones, WRT54. Once I'm here, I can go into the default guide, and it's going to show me exactly how to get into that router, how to set it up. So there's my address that it usually uses. There's the default gateway, which is the address that you'll use from the inside to get to it. There's your username and password. Again, if we don't know what the password is, we'll use the default. This is one of the locations we can go to get the default. I scroll down. Most of the time in Linksys router, it's under applications and gaming. So we would go in here, we would go into our settings, we would go into our applications and gaming, and we'd start creating rules. You'll see that a lot of recorders give you plenty of room for rules. If you're in a corporate router or a more corporate gateway or a corporate firewall, you'll have a lot of rules. So what we can do is create a rule here for the application. We'll call it DVR. The start port will be 80. The end port will be 80, meaning I come into port 80, I go back out port 80, and then my IP address is my destination. It's where I'm going to go. That would be the IP address of that recorder. So essentially what I need to do here is create 3 rules, one for the HTTP, one for the TCP, and one for the UDP. Once I'm done, I save my changes, and I'm good to go. That's how easy it is to set up routers. And again, we can provide that service. Your client's IT staff can do this for you. But if you run into an application where you're on your own, definitely know that you can go to portforward.com and it will show you very easily how to go in and set up your router for port forwarding. Another really helpful tool is, believe it or not, just Google image search. I can go into Google, go into images, type Linksys port forwarding or D-Link port forwarding or Comcast or Quest or AT&T, and it will give me a whole bunch of screenshots on exactly how to do what I'm trying to do. We'll go ahead and just click on this first image. Hey, there you go. That's what we did. I create the application. I put in my port. In this case, they're using 5400, but we're using whatever TCP or UDP or HTTP we want. Our protocol, our IP address, our enable, exactly what we just did. Here's a step-by-step guide on how to do it just by doing a Google image search. So keep that in mind. If you have the part number of your recorder or the part number of your router, you can go right here, do an image search for the manufacturer or the model number, and that will help you as well. So once you've done your rules, how do you test it to make sure it's working? I like to use canyouseeme.org. It's a great website, not only for finding out what your outside address is, what your public IP address is, but also for testing your ports. So for example, I can come down here, there's my outside IP address, that's my public address that was given to the client by the internet service provider. There are my ports. I can go to, say, 3 and 4/7, which is my TCP port. I check the port, success, it's done. So now I know that my ISP is not blocking that port. I know that when it queried the router, this utility went to my router, it saw something on the other side. It didn't log in or anything, but it says, yep, I've got an open port. I see something on the other side. I'm forwarding to a device. We're good to go. What would happen if I didn't have it? I know, for example, port 80 on our side doesn't go to a recorder. It's a blocked port. So it's going to rattle around a little bit longer, and it's going to come back and tell me fail. I can't see it. It's trying. It tried again. It tried 3 times and nothing. The connection timed out. So it tried and tried and tried, and it couldn't get through. This would tell you that there's no access here. The port forwarding rule is incorrect, or it's not there, or it hasn't been saved, it hasn't been enabled. So this is a really powerful tool, canyouseeme.org, to get to your device from the outside and verify that it's working. This is great to use, obviously, when you're inside the network. I couldn't see another network from this and test it remotely. Say my installer's setting up at the office or setting up at the house, and I'm at the office trying to test it. It doesn't quite work that way. I'd have to be inside that network in order to test it. But it's very cool that I have a great utility here to be able to find out, again, not only what my outside address is, but also find out that my ports are forwarded correctly. Let me take this back, do my 3 and 4/7 again. I like the success a lot better than the error. There we go. So you'll also find that this is very, very quick when it's successful. If it takes a little bit of time, it's going to be probably failing. So let's go ahead and talk about public IP addresses real quick. A public IP address, again, is given to your client by their internet service provider when they buy their service. We'll talk again on Friday about connectivity. We'll talk about bandwidth and required bandwidth and how to make the most of it. But one of the important things that your internet service provider is going to provide your client is an outside address. Now, there are two different flavors of outside address. There are static, which are addresses that never change. They stay the same forever. And there are dynamic, which are addresses that change quite often. Static IPs are used primarily in corporate environments. They're used in corporate networks. Dynamic IPs you'll see mostly in residential. Remember, there are still about 80% of the clients out there with residential internet service that don't ever have the need to log in. Their internet is designed for them to be in their living room surfing the web or watching Netflix or whatnot. They're coming down from the web into their home. So their IP address changing all the time is really no big deal. It doesn't matter what their IP address. That chunk of the market that you guys are interested in are the ones where they are sitting in a coffee shop downtown trying to see their cameras, or they're in a corporate security center trying to see all their different offices across the country. Those cases, static IP addresses are very important. You don't want to have an address be one thing and then you log in 5 minutes later and it's a different address. You're not going to be able to log in. So what do you do? Well, first thing is try to get a static IP address. A lot of internet service providers will provide static IP addresses if you ask. A lot of them will charge a pretty substantial upcharge if you need a dynamic or need a static IP address. Dynamic addresses are usually free. You're more than welcome to use our DDNS service, which is already built into the recorder. When the recorder is built to suit, it already is pre-registered with the ICDDNS server. So your client would put in a name. It would be patricksdvr.icddns.com. They would go to that name. The recorder has a client built into it to automatically update our server whenever that address changes. The client would go to the name and not the number. The name will stay the same forever. The number can change as often as you like. So that way, if the client is logging in from a coffee shop, they're going to go to Patrick's DVR instead of 6655, which could change on them at any time. So keep in mind that DDNS is available. It's a free service. There are other DDNS providers out there, of course, DyneDNS and others that are around that are certainly charging you for their services, but that's another option for you as well. All right, are there any questions? Cool, nice quiet class. Again, I am Pat Carter. I am the technical trainer here at IC Realtime. This is part of our regular webinar series, our public webinars. We will have this one again this afternoon at 4 o'clock Eastern Time. If you have any colleagues you think would benefit from learning a little bit more about networking, please have them join us at that time. Again, on Friday at 10 a.m. and 4 p.m., we'll be talking about connectivity. That's kind of the part 2 to this particular webinar. We'll be talking about actually setting your encode settings and working with difficult internet speeds. I want to thank you guys very much for taking the time to join us this morning. Again, if you want to contact me, I am Patrick at icrealtime.com. I handle all of our private webinars as well. If you want to schedule a webinar for your team on anything about product or technical or support or networking, I'm more than happy to accommodate for you. So please, again, if you want to reach out to me with any questions, Patrick at icrealtime.com. I want to thank you guys very much again for taking the time out of your day to join us, and we will see you at the next one.
Thank you, Patrick. Have a great